Okay, hello and good morning to all. So in the last class we discussed about the time division multiplexing. So in the time division multiplexing, time is the main component here, right? That means each frame, or you can say each slot, will be transmitted according to the time, right? With that means if your component of any source is not ready within that time period, that means it must wait for the next frame, right? That means enter transmitting will dependent upon the time period. So in the time division multiplexing, time slot again selection is directly proportional to overall system efficiency. So today we are going to discuss about another multiplexing technique. It's known as the coded division multiplexing. It is referred to as code division multiplexing (CDM) because each channel is coded in such a way that its spectrum spreads over a much wider region that occupied by the original signal. And CDM is used often for cell phones as it provides the most flexibility in a multi-user environment. It is also relatively secure because it is difficult to jam or intercept the signal in view of its coded nature. So it is a purely coded version. According to the figure, all the signals are in the coded nature, and the coding in such a way that its spectrum spreads over a much wider region that occupied by the original signal, right? So its spectrum should be, why necessary coded division? The coded division is required to increase the spreading area of the spectrum as much wider region than occupied by the original signal. Clear now? What generally our original signal capacity is very low, and its the occupying areas is very low. So restrength that original signal, this coded division is another method through which you can increase the spectrum area in your communication system. Next is your CDM is used often for all cell phones as it provides the most flexibility in a multi-user environment. It is also relatively secure because difficult to jam or intercept the signal in view of its coded nature. Though it is in the coded nature, that means all the signals in the coding form, so it is very difficult to intercept the signals. Clear now? Because though all the signals are in the coded form, so it is very difficult to intercept the signals or jam the signals. Clear? So that is another advantage of this coded division multiplexing. This one, the things are that is a channel method used by various radio communication technology, and CDMA is known as the coded division multiple access is an example of multiple access where several transmitters, you can say, can send information simultaneously over a single communication channel. This allows several users to share the band frequencies. You can say the band of frequencies, or you can say it is a bandwidth, and to permit this without undue interferences between the users. Clear now? So that is known as the benefits of the coded division multiplexing. So these all are about the multiplexing technique. Again, I am repeating that why using the multiplexing when the number of the consumers or clients is more greater than the available signals. In that case, the multiplexing technique is used. Here the more than one signals are combined to each other, and or you can say multiplex with each other and go through over a single channel, right now. So that is the technique of the multiplexing. So today we are going to discuss another thing known as the modulation, right? So modulation is the process of varying one or more properties of a periodic waveform called the carrier signal with a modulating signal that typically contains information to be transmitted. right? Here question is why the modulation process is required, right? Now modulation process is required to increase the strength of the original signal. Generally the original signals having so much strength to move a long distance or to journey a long distance, right? So for that reason there is a carrier wave or carrier signal is required to carry that original signal from the source to destination point, and that is the modulation technique. First example, suppose you write something on a paper right now and throw that paper simple on the paper, right? How much distance it will cover? Just 1 feet, 2 feet or 3 feet, then the paper will fall down, right? So when that paper is wrapping over a stone, right, over the stone, and throw the stone, clear now? So now the paper will move a long distance as compared to the previous distance. So now here the that stone acts as the carrier for that paper. Similarly, modulation is a technique. Your original signal having no such amount of the strength to move to travel a long journey from source to destination. So there is a carrier signals will added with that, and that carrier signals changes according to the frequency of the original signals, and that is the modulated signals. And this modulation is divided into two parts. One is analog modulation, that means these are the technique used for the analog signals, and the digital modulation, the following techniques are used for the digital signals. So before we are discussing or discuss briefly what is analog signal, it is a sinusoidal curve, right? It is a continuous form. And so many of components are added with that signals, analog signals. But the digital modulation, it acts in a particular format. That means 0 1 1 0 1 0 0 1. That is known as the digital. So in analog modulation, there again there are three type of technique: amplitude modulation, frequency modulation, and phase modulation. Similarly, digital modulation, there is a ASK, FSK, and PSK. Amplitude shift key, frequency shift key, and the phase shift key. So these three will now be these six. That means under the analog there are three types, and under the digital there are three types. So these all are discussed now. So first is your analog modulation. So under the analog modulation, the first one is your amplitude modulation. In amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting information via radio carrier wave. In amplitude modulation, the amplitude of the carrier wave is varied in proportion to that of the message signal being transmitted. So entire thing will be dependent upon the variation amplitude. So here frequency and phase both are in the constant. There are no changes in the frequency and the phase. Only the amplitude will be changes. Clear now? Again repeating, amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting information by radio carrier wave. In amplitude modulation, the amplitude of the carrier wave is varied in proportion to that of the message signal is being transmitted. So here amplitude is varied. So in this graph, now that is maximum amplitude, right? And this is the minimum amplitude, right? It is the amplitude modulated form, and this is the carrier. The amplitude of the carrier wave is varied according to the, or you can say the proportion of the original message signal is being transmitted. So I am repeating, your amplitude will vary according to the original signal. No effect of the frequency and phase of a carrier signal. Clear? So next is your again I am repeating, modulation is a technique where the carrier signal is modulated with the with the original signal, and there's a modulated signal which generated. Clear now? So in this technique, amplitude only vary, but frequency and fetch is the constant.